This video is to finish up the booklet, Introduction to Quadratic Functions, Unit 8. So I'm going to call it video 8.1 through 8.3. We're just going to tie up all the loose ends that we haven't gotten to so far. And just as a reminder from yesterday's lesson, Mrs. Miller went over a number of concepts, and just to highlight a couple of them. One is that if we have an equation in the format of ax squared plus bx plus c in standard form, you can put your equation into y equals and hit graph. And once you see your graph, you can find the vertex by using your calculator, by using the function second, and then hit the trace button, which is calc, second calc. And then you look at the list that it gives you, and if your parabola opens upward and has a vertex at the bottom, you're going to pick minimum. And if your parabola opens downward and has a vertex at the top, you're going to pick maximum. So you choose one of those two items and then follow the directions. The left side, put your spider on the left, and then you arrow over when it says right side, and we put it on the right, and then we hit enter again when it says guess, and it'll give us the vertex. So you'll get the coordinate pair, whatever that might be. Let's say it's 3, 2. Okay, in addition to that, she mentioned how if we know the vertex, and likewise then would know the axis of symmetry, if we know several points on one side of our parabola and we plot those on a graph, then you can use this distance that goes from the axis of symmetry to the point and go the same amount of distance on the other side and plot points that are the same distance away, and you're able to draw your parabola like that. So if you're given a graph that only goes halfway or partially, and it says to complete it, find some perfect points, go equidistant this way, plot them, and you'll be able to graph it. Okay, so that's just a quick review of some things she showed you yesterday. Now, today I'd like you to turn to page 5 on your booklet, and we're going to look at the bottom. You've already completed the top of that page, and on this little part we are going to show you some differences between linear functions and quadratic functions. So the first thing I would like you to do, where it says first, the first thing I would like you to do is to put these points into this table that's given here. So I'm just going to go 1, 2, 3. Now put these points in the y values: 10, 7, 4, let's see here, 1, -2, -5. Now, I tell you that this is a linear function, and I want to show you how you can know that for certain. As we go up the x's, we see they are increasing by a value of 1. If I look over here at the y's, when the x's are going up by 1, I see the y's are going down -3, -3, -3. It's going down 3 for each of these. So this, what we call the first difference in the y's, this is the first difference. It's a constant, and when the x's are going up by 1s, the y's are always going down by the same amount. So I know this is linear because this pattern occurred the first time I found the change in y's. When the x's are going up by 1s, these are all going up by the same. Now, I'm going to tell you that the next set of numbers is going to be quadratic. And so what I would like you to do is to place in the x's, let's start with -3, and then -2, -1, 0, 1, and 2. Now for our y values on this one, I would like you to place -12, -2, +4, positive 6, back to 4, and then negative 2. So in a way, we can see it seems to be quadratic because we started low with negative 12 in our y's, then it went up to 6, and now it's starting to go back down. So it seems quadratic. Again, let's look at our x's. Our x's are all going up by 1s. So this is a pattern that occurs when our values on the x column are going up by 1. Let's look at what the values are in our first difference on the y's. Between negative 12 and negative 2, we went up plus 10. And from negative 2 to 4, we went up plus 6. 4 to 6, we went up plus 2. And now we're going down 2. And now we're going down 6. From positive 4 down to negative 2 is negative 6. So obviously this is not linear, because if it was linear, it would have this kind of a pattern where they would all be the same. Now what I would like you to do now is look at the second difference. And we start at positive 10 and go to positive 6, we've gone down 4. And when we go to 6 to 2, we've gone down 4, minus 4. From positive 2 to negative 2, we've gone down minus 4. And from negative 2 to negative 6, down 4 again. So this second difference is constant. And when the second difference is constant, we know that we are looking at a quadratic equation. It's a pattern that's always going to occur. Okay, now on the third example, it's not so cut and dry. So personally, I like to look at these points in a table versus stretched out like this. So we have negative 3, 14, negative 1, 0, 2, negative 6, 3, negative 4, and then 5, comma, 6. Now, you look at your x values, they're not going up by 1s. They're not going up by any constant pattern because it went up by 2 here, then 3, then by 1, and then by 2. So there's no real pattern to our x's. So what I decided to do was to take these points and plot them in the calculator, and let's take a look and see if we can determine what kind of a function we're looking at. So you can do that by going to your calculator. Go to your calculator and use, we've done this before, use stat, go to your stat key, which is right here, and then edit and put your x's into L1 and your y's into L2, which you can see I've done that on the screen. Then make sure your plot has been turned on, and you can turn plot on by hitting your y equals key and then use your up arrow key until you see the word plot. Hit enter to lock it in so that the plot's turned on, and then hit your zoom key and number 9, and you can plot the points, which I've done right here. So we can see the points, and you can kind of see that these points are going down, and then it appears they turn around and go back up. Now, I don't know what the equation is on this, but we can use our calculator to figure it out. Okay, so what we're going to do is use the same way we found linear equations by using regression. We're going to do it with quadratics. So let's take a look. So do stat and then arrow over to calculate. I'm showing it there in the picture. And then instead of linear regression, since we know our graph was kind of going down and up, we're going to pick quadratic regression. So stat, calculate, number 5 for quadratic regression. And then you'll get to this screen. If you just want to get the equation, you can just hit enter, 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 enter until you get your equation. If you want to store your equation into y equals, which is what I like to do, when you get to this point right here, just arrow down until we get there, and then type in vars, hit the vars button, and then use your arrow to go to y vars. and then hit enter 4 times. Vars, y vars, enter, 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 and you'll get your equation. So this is what I got right here. You can look at the screen, and it's telling us that A is 1, B is -3, and C is -4. So we can write that equation as y equals 1x squared. So we're not going to put the 1 there. We're just going to write x squared minus 3x minus 4. And that's our quadratic equation that fits the points. And now, if you were to do zoom 9 again, so it would graph it, you can see that that line gives you the best fit line on those points that we just put in the calculator. I do not believe that equation is an exact equation for those points. It's just the best fit equation, and we used regression to figure it out. So let's just quickly review how we do that. We do stat and then edit. Make sure your plot has been turned on. We use zoom 9 to see that the points appear to be quadratic. They're going down and then back up. And then to get the equation, we did stat, calculate. We picked number 5 for quadratic regression this time. And then we arrowed down until we got to the store equation and put vars, y vars, enter, 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 enter. And then we got this equation here. And then zoom 9 again to see the equation and how it fits the points. Okay, so there you go. Now let's turn the page and go to page 6. Okay, so at the top of page 6 we have a graph, and it says the graph represents the relationship between the height in yards and the horizontal distance in yards of a soccer ball after being kicked. And so we're going to answer a few things. The first thing I'd like you to do, even though it's not listed on here, let's talk about the domain and range. Because so far, all of the equations we've done in this booklet have just been what we call raw equations. We've been graphing them in our calculators, and we've been seeing our parabolas. They go on forever. And the domain has always been all real numbers, even the ones that go upside down. The domains have all been all real numbers. But we can see in this real life situation that our domain, which goes from left to right, starts over here and ends over here. So if we were going to write the domain, we would say the domain is 0 is less than or equal to x, which is less than or equal to 65. And our range, which goes from bottom to top, starts again down here on the 0 line and ends up here. It stops. So our range is going to be 0 is less than or equal to y, which is less than or equal to 9. So that's the first thing I wanted to point out, is that in real life situations, no longer do we have the all real numbers and all the y's are greater than or equal to 0 kind of thing, or greater than or equal to 2. You have to look specifically at the numbers and get the domain and range. Now, let's look at the questions it's asking us. So it says, find the following values, f, and then in parentheses, 7.5. So you need to remember from last semester, when we have a function, when we have f of x equals, and in this case, it's a quadratic function, ax squared plus bx plus c. F of x is another way of saying y equals. So when we get something like this, where it says f 7.5, it's saying, what would our function, what would the value of y be if we put 7.5 in for this x? If we were to put 7.5 in for x, what's the value of y? Now in this case, we don't have to plug it into a function. We're just going to look at the picture. We're going to look at the graph. And so let's find where x is 7.5. And you'll notice these are going up by 5s, and so the halfway mark, it's going up 2.5. So 7.5 would be right here. So let's go up to our graph and see that it appears to be approximately 3.5. I'm going to say it's 3.5. We don't know exactly, but that's pretty close. Now, how about 22.5? So again, every line is 2.5, so 22.5 is going to be right here. And so we're going to go up, and we're going to see what it is, and it looks like it's 8. Now, it says find the value when f of x equals 2. So remember, when you see f of x, that's like saying y equals. So what's the value of x when y equals 2? So here's where y equals 2, and so I'm going to travel across my graph, and we have a point there, but we also have a point over on this side. And again, those are not exact, but it's approximately what? I'm going to say it's about 4, because this is 2.5, this is 5, it's somewhere in between. And then over on this side, it's less than 62.5, so let's call it approximately 62. How does that sound? Okay, so far so good. When you see the number in the parentheses, that's giving you the x and asking you for the y. When it says f of x equals 2, it's saying it's giving you the y and asking you for the x. Okay, now at the bottom, we are going to try and get the equation for this graph. Now, to find the equation, we're going to use regression, again, what I just went over with you a minute ago, using our calculator. And in order to do that, the best thing to do, not the best thing, the thing you need to do is find perfect points. So we have some perfect points on this graph, and one of them is the starting point and the ending point. So we know there's a 0, 0 on this graph, and I'm down here at the bottom. I'm going to put 65 and 0, and let's find some points in between that are perfect. So one that we just did a moment ago was 22.5 was at, I said it was 8, but I think it's 7. Let's look. Now, it would help if I went to 22.5 instead of 17.5. Sorry about that. Let's go up here. It is 8. So there we are. So 22.5 is 8. And then I see another perfect point right up here on the vertex. And that would be 32. Come down here and we can see that's 32.5. And that point's 9. And let's go over and find this same point right over here. It's the same one. So again, we're at 8 and then 42.5. Now that we have those points, let's use our calculator to get an equation. And so I have a series of 3 pictures of my calculator. Here's where we went to Stat, Edit, and I put in our points, our perfect points. Then we used Stat and then arrowed over to Calculate, and then we're going to pick number 5, Quadratic Regression, and we're going to continue to hit Enter until we get our quadratic equation. So let's round this to the nearest thousandth, so that would be 3 decimal places. So we're going to go past the 3rd place and see if we need to round up. So A, it appears as negative 0.008 x squared. B is, we're going to go past again, so we are going to have to round it up, so that's going to be plus 0.548x, and then no rounding necessary on the last point, negative 0.005. Let's put y equals at the beginning, and there's our quadratic equation that we were able to get using regression. Okay? So last page and we'll finish her up. Okay, so on the back it says evaluating quadratic functions, and it says given this function, find the range What's the range? The x's or the y's? That would be the y's. Find the y's when the domain, which is the x's, is this. So, look, the easiest and simplest way for you to do this is to take this quadratic equation, put it into y equals in your calculator, just type that into y1, and then go to second graph, which is your table, and look on the table, and let's get the values. So what I'd like us to do is just make a little table. We have -3, 0, 1, and 5. And let's fill in with the values that we get. So you get 16, you get -5, you get 0, and you got 80. And you've got to remember that when we're writing the domain and range, the domain goes from left to right, which is lowest to highest, and range goes from bottom to top, again from the lowest to the highest. So we want to go in ascending order, and so we need to find the lowest number. So in our little group of numbers here, the lowest one is -5, and then 0, and then 16, and 80. So that's how we would write the range. Now you can do the same thing with the next one. It says, given the quadratic function, and here it is, find the range, which is your y's, when the domain x is this. So again, I highly recommend you do something to keep your work organized. I like to make a table, so I'm going to put -31, -9, 5, and 22. Then I'm going to use my calculator to get the information. So I've got, for -31, I've -4,861, -417, -109, and then -2370. And again, we're writing the range. So the range, we want to go from the lowest to the highest. So we'll start with our lowest number, 4861. Oh gosh, I'm making a mistake. Sorry. And I don't have very much room there. I have more room on my paper than I do on this iPad. I'm going to write it down here. Range. And there you go. I have them written out. From the lowest one, which was -4861, up to the highest, which is -109. Okay, so do the last one yourself, and you can check your work here in just a minute. So hit pause and give it a try. So on this one, I hope you have 2145, and then 0, and then 10, and then 3741. As your answers, you can look over here at my pictures. I decided to set my calculator to ask. If you don't remember how to do that, you hit second and then the window button, and then arrow down until you see it where it says ask, and hit enter to lock that in. That way I could just type in the numbers that I actually wanted for my x's. And so you can see the answers right there. And then again, we want to write our range. And I failed to mention, and I apologize for this, when we see numbers inside those parentheses, it's giving us the x, and it's asking us for the y. So it was asking us for the range. And again, we want to go from low to high. So we'll do 0, 10, 21, 45, and then 37, 41. And that's it. So you guys have gotten a really great overview of a lot of things related to quadratics. We still have more to come, but that's all the basics. And of course, if you're having trouble with any of this, please come see Mrs. Miller or I during tutoring. We're here to help you and help you have success. Okay? So see you in class. Bye.